Okay, 7.2 is about multiplication and division of fractions. All right, it's about multiplication and division. So I'm going to ask you to remember some simple things about multiplication and division. When you multiply two fractions, let me go to a blank piece of paper. And what if I ask you to multiply, and you don't necessarily even need to write this down if you're taking notes. I'll come back to the problems. What if I ask you to multiply 12/15 times 5/16? Do you agree you could, if you wanted to, multiply the tops, multiply the bottoms, and then try to reduce your answer? Or you can look this way, this way, this way, and this way to see if maybe you could reduce or simplify beforehand. And what did I end up drawing? A bow tie. Kind of missed the knot, but there we go. I have a bow tie. So it's a little bit silly, but I'm going to say bow tie before you multiply. Yes, I rhymed. Bow tie before you multiply. Okay, you're probably way too mature for that silliness, but it will help you remember. You're going to look in all those directions to see if there's some reducing. Now, I hope the purple doesn't make it too hard to read. What could I reduce in this arithmetic fraction? 12 and 16 have a common factor of 4. 4 goes in there 3 times. 4 goes in there 4 times. What else? 5 and 15 have a common factor. 5 goes in there once. 5 goes in there 3 times. Do you see anything else? The 3's, and sometimes the vertical is overlooked. 3 goes into itself once. 3 goes into itself once. Multiply the leftovers, and sometimes it's hard to even see the leftovers. What would you get? You would get 1/4. Is that okay? All right. The other thing I'm going to ask you to remember is about division. This is just arithmetic stuff. What if you had 5/8 divided by 20/36? What do you have to do with a division problem? Okay, my little silliness here is going to be keep, change, flip. You're going to keep the first fraction exactly as it is. You're going to change the operation to its inverse, which is multiplication. You're going to flip, which is another inverse, that to 36/20. And now you will, quote, bow tie. What do you see that we could do? The 5 and the 20, okay, 5 goes in there once, 5 goes in there 4 times. What about 8 and 36? Do they have a common factor? 4 is the greatest. You could do 2 and then do 2 again, but 4 goes in there 2 times and 4 goes in there 9 times. Anything else? I don't think so. We get 9/8. And in here, we're completely happy with improper fractions. So does everybody remember how to multiply and divide? All right. We're going to do it now with algebraic fractions. And let's see. I have all these problems here, but I'm going to go ahead and go down to notebook paper and write them. Okay, problem number 1. You're supposed to multiply 3x over 4w squared times w over 7x. Bow tie before you multiply. And in this problem, these are monomials. These are already in factored form. It's already 7 times x, 4 times w squared. These don't need to be factored. Do you see any common factors, though? Okay, somebody said the x's. This x and that x. Divide out. What else do you see? W's. I have a single w here. I have w squared down here. So if I divide it, do you agree I get one w down there? Anything else? I don't think so. What do I have left? I have a 3 in the numerator. The denominator, I have 4 times w times 7. So I will call that 28w. When you finish a problem and you're ready to say it's done, always look at it and make sure you haven't overlooked some factoring that you missed over here. We didn't miss any, but I always look at it just in case. Is that okay? What do you have to do? These have to be in factored form. They already were in problem number 1. Problem number 2. I have x over 7x minus 35 times x squared minus 5x over 3. All right, I believe I can, when I see some pluses and minuses in here, it tells me I better look at these and see if they can be factored. Can the numerator of the first fraction be factored? No, it's just x. Can the denominator of the first fraction be factored? What do you see? 7 as a common factor. So 7 and the other factor will be x minus 5. Is everybody okay with that factoring? Times, second fraction, numerator. Can I factor this numerator? What do you see? Common factor of x, x times x minus 5. The denominator is just a 3. So when you're going to multiply two fractions, you could have as many as 4 factoring problems to do in one problem. I only had 2. All right, do you see some common? X minus 5 and x minus 5. What about the x's? No, they're both on the top. Okay, I just wanted to tempt you with that, and I'm always going to do those mean kind of things. You just be firm and tell me no, you can't do that. So what do I have left? On the top, x times x is x squared over 21. That is the product, and it's in lowest terms. It is simplified. Let's look at number 3. The original problem is x squared minus 49 over x squared minus 5x minus 14 times x plus 2 over x. All right, before I do anything, what do I have to do in each of the 4 positions? Factor. Factor, factor, factor. You got to remember to always start out with that. First numerator, x squared minus 49. What comes to mind? Difference of squares. Y'all are getting really good. Difference of squares, that's going to factor into x plus 7 times x minus 7. And on the recording, that was someone very tired. All right. The denominator, trinomial, no common factor. Let's go with trial and error. The last sign is negative, which means I have 1 of each. I have x and x. I need factors of 14, which have a difference of 5. 7 and 2. And I will put the 7 with the negative because the middle term was negative, and the 2 there. And you would double check that. The second fraction, I don't think there's anything we can factor. X plus 2 can't be factored, and good old x can't be factored. So what do you see as common factors? I hear x plus 2, and I heard x minus 7. So what are we left with? The numerator is x plus 7, and it's over x. Okay, go ahead and mark out the x's now. No. Tell me no. That x belongs to the plus 7. You can't touch part of it without touching all of it. Okay. Number 4. All right, we've got a lot of trial and error in this problem. We have a squared plus 13a plus 40 over a squared plus 5a minus 14 times a squared plus 8a minus 20 over a squared plus 16a plus 64. I'm going to be quiet, pause the recording, and give y'all a couple of minutes to be working on this factoring. Okay, we have 4 trinomials to factor, and I will solicit help from the class. The first one. I know the last sign is positive. They both match the middle term, plus and plus, a and a. I need factors of 40 that add up to be 13, 8 and 5. Doesn't matter which one you put where. Denominator. There's no common factor. I'll go with trial and error, but this time the sign is negative, which tells me one of each. I need an a and an a. I need factors of 14 that, because the signs are different, have a difference of 5. 7 and 2. And I need the 7 to be positive because that was what the dominant one was, and the 2 down there. Okay, the numerator over here. Last sign is negative, so I need 1 plus and 1 minus. I need an a and an a. I need factors of 20 with a difference of 8. 10 and 2, with the 10 being the bigger one, has to go with the positive. Last one, I have last sign is positive, middle sign is positive, so they're both positive. I have an a and an a, and 8 and 8. 8 times 8 gives me 64. They add up to be 16. Okay, so however long it takes us to get through all that trial and error factoring. Do you see any common factors for me to divide out? Okay, I'll just, whatever you tell me. Okay, I heard an a minus 2, a plus 8, and is that all? I think so. Now, my math lab, for the most part, does what most math textbooks do. When you have a product multiplication problem, it leaves the answer in factored form. So it leaves the answer looking like this. And you do not have to use your FOIL to multiply it out. So don't FOIL. You're just going to leave it. All right, so when you get an answer like this, don't multiply it out. Just leave it. But I will tell you there's one inconsistency, and I'll tell you which problem it is where they do multiply something out. But I'll tell you about it so you'll know. All right, let's go. Is everybody okay with multiplication? Yeah. Okay. Let's go to division. Problem number 5. It says, find the quotient and simplify the result. Now, I may need just a little bit more room here. So, all right, the problem is 7x to the 5th over 2x to the 6th divided by 21x to the third over 10x to the fifth. Because it's division, what's my first step? All right, I've got to keep 7x to the fifth over 2x to the sixth, change it to multiplication, flip the second fraction, so it is 10x to the fifth over 21x to the third. These are those monomials again. These are not pluses and minuses, so I can go straight in there looking for common factors. What do you see? Let's do numbers first. 7 and 21. 7 goes into itself once. 7 goes into 21 3 times. What else do you see with numbers? 2 and 10. 2 goes into 2 once. 2 goes into 10 5 times. Now, with the x's, do you see lots and lots of factors of x's? There's a lot of ways you can go. You could work up and down, or you can work on diagonals, or maybe both. Any way you want to go is okay. So, it's going to get a little cluttered. How do you want me to go? Diagonal. Somebody says diagonal, I'll go with it. So I'm going to start out by looking at an x to the fifth and the diagonal x to the sixth. If there are 5 factors of x up here and 6 of them down here, do you agree that 5 of those will go away and you'll have a single factor of x left over? Okay. Now let's look at this diagonal. I have an x to the third and x to the fifth. These 3 will knock out 3 of these, leaving x to the second. And I'm not quite done, even though I have a big clutter of red marks up here. I took care of my numbers, and I've taken care of my variables, but I still have an x to the second over an x. So can I still reduce further? Yes. This x divides out with one of these x's, leaving me an x up there. So what in the world do I have left? I have 1 times x times 5, which is 5x over 3.
Would you get the same answers if you do up and down?
Yes. You could do up and down x's and then see if there are any diagonals left. All right, number 6. It seems as if MathLab sort of breaks its own rule with something with number 6. So I'm putting a little circle around it because when you do number 6, I'm guessing the same thing's going to happen. All right. Starts out as a division problem. So I have a squared minus b squared over a minus b divided by a over a squared minus ba. All right, first thing I need to do is keep change flip. Keep the first one, a squared minus b squared over a minus b, change to multiplication. Invert the second fraction, a squared minus ba over a. Now what do I need to do? I'd like to bow tie. Before I can bow tie, I have to factor. If you work through a problem and you haven't factored, the only kind of problem that you should be doing that on would be one like this, where there is no factoring to be done. But if you've got any pluses or minuses, you better be factoring. All right, numerator of the first fraction. What do you recognize? Squares, difference of squares. A squared minus b squared. It factors into a sum and a difference. A plus b, a minus b. Denominator. Is there anything I can do with the expression a minus b? Okay, numerator of the second fraction. Is there anything I can do to factor this one? Greatest common factor of A. A times A minus B. And is there anything I can do to the denominator? No, it's just an A. Do you see any common factors for me to divide out? Yes. Here's an A minus B, and here's an A minus B, although you could have done the up and down ones. It's your choice. What else do you see? Just the single factors of A. So I think that leaves us with A plus B times A minus B. Now let me say this. If you were taking a test, I would think that would be your final answer. Leave it in factored form. That's what I'm always going to say to do. I'm so sorry. For some strange reason, my math lab decided only on problem number 6 to multiply those together. I don't know why. But if you multiply those, it's a sum and difference product. You're back to A squared minus B squared. On this one, MML multiplies. And I don't know why, and I wouldn't. But I'm assuming that you'll need to as well. All right, there are a gazillion problems. We're going to skip several. All right, if you take a quick look at number 7, the only thing in number 7 that I would call your attention to is this denominator is an 8 minus x. When you do keep, change, flip, you're going to have a numerator that is going to be, you're going to have an x minus 8 up here. What do you notice about 8 minus x and x minus 8? They're opposites. So when you divide those out, make sure you leave a factor of -1 with your answer. Okay? So I'll just mention that on number 7. We're going to jump. There's a multiplication problem on number 8. Number 9 has a multiplication problem, and we're going to go all the way to number 10. And this will be our last problem. All right, it is division, so let me write it out where those of you in the classroom can see it. It is 28n squared minus 847 over 2n squared minus 15n plus 22 divided by 6n squared plus 23n minus 55 over n squared minus 8n plus 12. Now that's the original problem, but it's division. So we all have the joy of rewriting it as a multiplication problem. It is 28n squared minus 847 over 2n squared minus 15n plus 22 times, flip the second one, n squared minus 8n plus 12 over 6n squared plus 23n minus 55. Okay, now something I'd like to do is that this looks like quite a bit of factoring. Agreed? I'm going to go off completely down here and just write out my factoring. The first one is 28n squared minus 847. What can I do? Do you think there might be a common factor? I hope so, because that's a square. So I'm hoping for difference of squares, but 28's not a perfect square, and I don't think 847 is. So I've got some of y'all with calculators piddling with it. What will go into both of those? Seven. Somebody says 7. Now here's something that might have been a clue. 28. It's not a perfect square. What are the common factors of 28? 4 and 7? 4 is a perfect square. I'd like to keep it, which means I'd like to factor out the 7. Check and see if 7 goes into that. It does. If I factor out the 7, 7 goes in there, 4n squared. And if I factor out the 7, I get 121. Well, is that binomial the difference of squares? Yes. Keep the 7. 1 sum, 1 minus. That gives me 2n plus 11 and 2n minus 11. That was all to factor the first numerator. Back to my problem. So I have 7 parentheses 2n plus 11 times 2n minus 11. Is everybody pretty tired? Would you like me just to write down the correct factors for all the others? Do you want the challenge? All right, this bottom one. Let's see if we can just do it. It shouldn't be too bad because that's a plus, which means both factors are minus minus. I know one of them has to be a 2n and one of them has to be an n. I need factors of 22. What do you think I'll use? 22. 2 and 11. 11 and 2. Check them. They're right. I made them happen. I have the answers written right here. It's called cheating. Okay, this numerator, the last sign is plus, which means both signs match the middle term. They're both minuses. I need an n and an n. I need factors of 12, which add up to be 8. 6 and 2. This denominator, there are quite a few possibilities. And I am going to save us a little time. We know that the last sign is negative, so I need 1 plus and 1 minus, and I will get 2n plus 11 and 3n minus 5. There were probably quite a few possibilities there. So, we have all of this. Do you see some common factors? Yes. I see a 2n plus 11 and a 2n plus 11. 2n minus 11, 2n minus 11. n minus 2, n minus 2. Okay. In my first class today, when I was doing this problem, I miscopied the problem. Nobody said anything. So we did all this, and the problem I made up was factorable. We got all these factors, and nothing canceled out. They were upset with me, especially when I said, oh, that was the wrong problem. We need to start that one over. I wasn't popular. It's a good thing I couldn't read their minds. All right, so I have 7 times n minus 6 over 3n minus 5. And you really should not multiply that 7 times those, and I checked the answer on this one, and MathLab doesn't. Only number 6 did I find that it multiplied anything out.
You don't put one of those like this.
I would not. No. There could be one with 4 things to factor like that, but not something with all these possibilities. No. Okay, so are we good with that? And I'll say some concluding remarks.